Hey Christine, um, so this is how I use Delta, but in this, I downloaded it here, but this is usually how I read stuff like this, like the COSY and the HMS or HMQC. Those are always hard to say. So I'm gonna go to my files and try to get it out, both of them. Well, first I'm gonna show you the Proton. Let's see if I can get there. Okay, so this is the Proton. And if you zoom in a little bit, as you can see, yes, it is kind of messy, and it's hard to tell which peaks are which. So, I mean, I can kind of see a triplet here and a triplet here, and I see some the doublet, but none of those, you never can really know for sure whether they're part of your product or not, unless you use the COSY. And that's what the COSY is for. That's the proton-proton 2D NMR. And it tells you for sure which peaks would possibly come from your product. So that's why we do it. So let's get out the COSY. So I'm going to try to get it over here. Let's see. This is the COSY. So it just takes a proton and proton and puts it on these two axes. So you can see these dots here. We're more likely interested in the aromatic region. That's literally where all our peaks are. So let's zoom into there. All right, so we have these. And in a COSY, and usually with any 2D NMR, the peaks that you're probably going to be more interested in are the ones that are on the diagonal. Peaks on the sides of the diagonal, like this one, this one, this one, this one, or that one. Those are probably ones that you don't want to focus on for initially. You want to focus on that first, the ones on the diagonal. And then if you have to, you can go off the diagonal. So, and the reasons for that would be to see which peak is next to another. But usually for this experiment, you're really going to find out. It'd be better to find out which ones are on the diagonal. So this is the diagonal, just right here. This very intense one right here is probably going to be our deuterated chloroform peak, which that's not going to be part of our product. I know it's easy to be tricked, but you're seeing this peak there, but if you click this tool and then go over it, you can see it's around 724, which is about the ppm of a deuterated chloroform peak. So that's not part of our product. I can see a peak here at 7.41, and I think it's part of our product. There's another one here at 715, another one here at 718. Make sure the numbers are the same, like the X and Y values, they should be the same. So, or close. Here, they're the same. So, 715. So, I guess a good way to know if one peak is on the diagonal or not is if the X and Y values are near the same. Here, they're near the same. So, it's on the diagonal, and it's probably going to be part of your product. Here, same deal. 7.41 as X and 7.41 as Y. So, it's probably also going to be part of the diagonal. This here, you can try to move it a little bit, but I think you can make both of them 7.18 or 7.19. See, yeah, 7.18. This peak is probably also going to be part of your diagonal. This one may also be part of the diagonal too, but it's not part of your product since we already mentioned it's the deuterated chloroform peak. We're supposed to see 4 of them though. I'm guessing, my best guess is just that one of them might be buried somewhere, or really on COSY, if you think some peaks are missing, what you can do is enhance it. And on the Mac, what you can do is press the key Control and then scroll your mouse. So I'm gonna press Control, and then you can try to scroll your mouse up and down and see what happens. It's hard to do this while holding the phone, but I'm going to set the phone down for a second. I'm going to press Control. I'm going to scroll my mouse a little bit. So I scrolled my mouse just a little, and now you can see a little bit more detail. You can even see a peak here. It's about 738, and you can see the one down here too. But it's not, as you can tell, it's definitely not part of the diagonal because the X and Y values are different. But in here, the X and Y values are the same, more or less the same. So that could be part of the diagonal. So that could actually be part of our product. So that would make 1, 2, 3, 4 peaks, I would assume. But yes, COSY is a good way of finding out which peaks on the proton are part of your product. Now let's go to HMSQC. So we can go over here and get that out quickly. But actually, before we go to HMSQC, let's look at the carbon. And not the carbon we have, the carbon that Lee gave us to look at. Because Dr. Lee gave us a carbon NMR that actually has all the true peaks. So if you look down here, these peaks right here, as you can see from here, these are what we saw in our carbon. And these were literally the only peaks that we saw in our carbon, just these 3 right here. But apparently we are missing some. And it's not like we didn't do it right. It's not like we did it wrong. It's just the fact that we didn't let the carbon run long enough. But these same 3 peaks are in our product. So that's good. We've made it. To zoom out, and it took me some time to figure this out, you actually go to here and press Reset View. So now we're back to the home screen. This is the peak we're missing. The one at, I think, 127. That's the one he was saying we are missing. And that's one was also part of our product. This peak here, I think could be the quaternary carbon, because quaternary carbon peaks on carbon NMRs, on carbon spectra, are usually really tiny. And he told us to find a quaternary carbon. And I think this one could possibly be the quaternary carbon, aka the carbon that doesn't have hydrogens. So yeah, this is the full carbon spectra, and they also give you the values down there very nicely for you to record and observe. But yeah, that's the carbon NMR. And what an HMSQC does is it takes the carbon NMR and combines it with the proton. So then you could be able to see which proton peaks align with which carbon peaks. And that can be very useful. So let's go down to the HMQC. This is the HMQC. Again, you would want to use the same rules as you did with the COSY. Find the ones that are on the diagonal, or the ones where X and Y are the same. We can try to observe this part here, because this is the proton, as you can see, and this is the carbon. We were more interested in those around the 77 range, I think, for carbon, and then those around the 7 range for proton, because that's the aromatic region. So we can maybe zoom in on here, this region here. So we see some peaks here. This is the deuterated chloroform peak, and I can prove it. You can click here and go there. You can see that's around, the X value is going to be your proton, and then the Y value is your carbon. So actually, never mind. Disregard what I said about X and Y being the same. They're actually going to be different in this case. In HMSQC, the X is the proton, and the Y is the carbon. I hope I didn't confuse you. So you're basically just going to find out the peaks that you found from your COSY, and you're going to see which carbon peaks align with which proton peaks. I haven't completely finished this, and I will tell you my findings later. Show you my findings later. I'm going to enhance this a little bit. So again, I'm just going to click the control key and scroll on my mouse to enhance this. So I enhanced it a little bit. You see this one here. This one here, I think it's around 7.34. Actually, what am I saying? Actually, never mind. But yeah, you could just like scroll and then find the peaks that you assigned from your COSY. Make sure you just try to compare them. Maybe I will give you a good example. A better example. Let's see. If we go around, maybe according to what I have assigned, there was one around 128 on the carbon. Let's see if we can find it. So this is around the 128 range. Let's see if there are any proton peaks that align with that. I think for mine, the one at 718, if you look on the COSY, there's one that we confirmed that was at 718, and I think that could be around here somewhere. Yeah, 718. That's the proton. It's hard to see it. 718, that's for X, and that's the one of the proton peaks that we assigned. And then the Y is one of the carbons that was assigned, 128. So then that means this peak here is actually going to be the carbon for that proton peak. So that's an example that's one of the examples, a good example I can advise you to consider. Other ones are a little bit hazy, but this one, I'm pretty sure that would be the peak. That's my dad. But definitely, don't be afraid to shoot me a text if you have questions. But yeah, HMSQC is a bit weird, but it's really just comparing and seeing which proton peaks align with which carbon peaks. And if you see a peak on there that shows that, then you can confirm it. Hope you have a great night. And good luck in your other classes. I'm sure you probably already had homework in other classes too, so I don't mean to let my time or this video keep you, but if you can, show me your results too. So, but thank you, I appreciate it.